Have you ever stopped to wonder how the digital world actually keeps track of, well, everything? I mean, from your social media feed to your Amazon cart, it's all just data. And that data needs to be organized, like, perfectly. Today, we're going to unlock that secret. Let's dive into the 7 types of database keys that make it all possible. Okay, so just think about this for a second. Your bank, right? It's got millions of customers. So when you whip out your phone and log into the app, how does it instantly find your balance, your history, and not, your neighbors, all in like less than a second? How on earth does it pinpoint that one single needle in a truly massive haystack? Well, the answer is actually pretty simple, but it's also incredibly powerful. They use a system of digital keys. Now, these aren't physical keys, of course. They're unique codes that unlock and organize every single piece of information, making sure everything is fast and, most importantly, accurate. So, here's our game plan. We're going to start by meeting the hero of the story, the one main key. Then we'll check out the other contenders for that top spot and see how these keys actually build bridges to connect all our data. After that, we'll get into some specialist keys for the tricky situations. And finally, we'll tie it all together and see why this stuff is basically the invisible backbone of your digital life. All right, first up, let's meet the absolute star of the show, the hero of any database. We're talking about the one main key. Its whole job is to be the ultimate one-of-a-kind identifier for every single thing. And that hero has a name, the primary key. Its mission, if it chooses to accept it, is to make sure that every single row of data, what we call a record, can be found with zero confusion. It's the official, undisputed ID number for that piece of information. And listen, you don't just get to be the primary key. You have to follow 3 golden rules, and they are non-negotiable. Rule 1, you have to be totally unique. No 2 records can ever share the same primary key. Rule 2, you cannot be empty, or what we call null. Every single record needs an ID, period. And rule 3, there can be only one, just one primary key per table. Think of it like this: one table, one boss. So let's see this in the wild. In a simple students table, just like this one, student ID is the perfect primary key. It's a no-brainer. No 2 students are ever going to have the same ID, and every single student has one. So if we need to look up Bob's grades, we just search for student ID 102. It's simple, it's fast, and it's totally foolproof. But hang on, how do we actually decide which piece of information gets to be the primary key? Sometimes a table has more than one option that could do the job. And this brings us to what I like to call the key contenders. So any field that has the potential to be the primary key is called a candidate key. You can think of these as all the nominees for the top job. They're all unique, none of them are empty, and a table could have a few of them all vying for that top spot. I find it easiest to picture it like a key election. Step 1, you identify all the potential candidates. Step 2, you hold the election and pick the absolute best, most reliable one to become the primary key. So what happens to the candidates that lost? Well, they don't just go home, they get a new important title. They become alternate keys. Check out this employees table. See, in this case, both the employee ID and the email are guaranteed to be unique for every single employee. That makes them both really strong contenders. They're both candidate keys. So which one should we choose? Most of the time, you'd pick employee ID. Why? Well, it's stable. It's never going to change, but an employee might change their email address someday, right? A good primary key should be rock solid. So employee ID wins the election and gets crowned the primary key. And our runner-up, the email field, now becomes the alternate key. Still unique, still useful, just not the main identifier. Okay, so keys are amazing for keeping things tidy inside one single table. But where they really show their power is in connecting multiple tables together, creating this whole web of related information. Let's see how that magic happens. This is the job of the foreign key. You can think of it like a diplomatic passport. It's a field that lives in one table, but it's actually the primary key in another table. And this connection is everything. It's how we link a customer to their orders or a student to the classes they're taking. Let's make this real. Here's a customer's table. Simple enough. The customer ID is our primary key. It's what uniquely identifies Frank and Grace. Okay, now here's our orders table. You see that customer ID column? That, right there, is a foreign key. We call it foreign because its real home is over in the customer's table. It points back to C001, telling us, hey, Frank bought the widget and the gadget. That simple little link creates this incredibly powerful relationship between two totally separate sets of data. So we've covered the big players, but sometimes you run into weird situations where you need more specialized tools. So let's meet a few of the specialist keys that database designers use to solve unique problems. We're going to look at 3 of these specialists. First is the composite key, for when you need a little teamwork to get the job done. Then there's the super key, which is, let's just say it's a broader category for anything that can uniquely identify a row. And finally, the unique key, which is a very close cousin to the primary key, but with one major twist. First up, the composite key. This is your go-to when no single column by itself can guarantee that every row is unique. Think about signing up for college classes, right? A student ID will show up many times if they take many classes, and a course ID will show up many times for all the students in it. But the combination of a specific student ID plus a specific course ID, that can only happen once. That combination, working together, is the composite key. Now, before we get to our last specialist, we need to quickly talk about a super important concept in databases, null. Now, null does not mean 0. It's not a blank space. It's a special marker that literally means no value exists here. For example, maybe a customer doesn't have a phone number on file. That field would be null. It's the official technical way of saying, we just don't know. And that brings us to the unique key. It acts a lot like a primary key. It makes sure every value in a column is unique. But there are 2 huge differences. First, a table can have more than one unique key. But second, and this is the big one, a unique key will allow one and only one of its rows to be null. This is perfect for something like an optional but unique ID number, where most people have one, but it's totally fine if one person doesn't. So we've talked about 7 different kinds of keys, but at the end of the day, why does any of this matter? Well, because these keys are the quiet, invisible architects of our entire digital world. All right, let's do a quick recap of the whole crew. You've got your identifiers, the primary key as the boss, chosen from a pool of candidate keys, and the runners-up become alternate keys. You've got your connectors, the foreign key, building bridges between tables. And finally, your specialists, the composite key for teamwork, the unique key for flexibility, and the super key as the umbrella category for anything that works. This entire elegant system is what keeps our data lightning fast, super reliable, and always accurate. From your bank to your Netflix queue, these 7 keys are working 24/7 behind the scenes. They're what bring order to all that digital chaos. And that's the real takeaway here. This isn't just about databases, it's about structure, which really makes you think, what other invisible systems are out there quietly organizing the world around us every single day?